This question is on the topic of chemical calculations. So in this question, we are given a reaction where ethene, C2H4, is reacted with oxygen to produce carbon dioxide and water vapor. So a feature of this question that you must take note is this, that in the question we are told that 1 mole of ethene reacts with 4 moles of oxygen. So the feature that we need to take note is this, that the amount of both reactants are given in the question. And when the amount of both reactants are given in the question, chances are it is a limiting excess type of question. Now for this question, it will be best solved using what I call the ICF, Initial Change Final Table. So what is the Initial Change Final Table? I'm going to show you now. So initially, we have 1 mole of ethene, 4 moles of oxygen, and then initial means before any reaction, so there are no products that are formed yet. Now what does change means? Change means the number of moles of each reactant that's undergoing reaction and the number of moles of products that are formed. So what do I mean by that? If we look at the ratio given by the balanced chemical equation, I hope you can see that 1 mole of ethene will only react with 3 moles of oxygen. And there are 4 moles of oxygen present, meaning oxygen is in excess. Now as mentioned, 1 mole of ethene will undergo reaction. So the change is -1 because it will be reacted in the reaction. And 1 mole of ethene will react with 3 moles of oxygen. So -3 represents that 3 moles of oxygen will be reacted away. Now let's look at the products. 1 mole of ethene after reaction, according to the mole ratio, will produce 2 moles of carbon dioxide. It will produce 2 moles of water vapor. How do I get that? Again, is by comparing the molar ratio. So that leads us to the third row, which is final. Final means after the reaction. After the reaction, my limiting reagent, I will have none remaining. Okay, the excess reagent will have some remaining. So I will have 1 mole of oxygen remaining. I will have 2 moles of carbon dioxide present, which is formed. I will have 2 moles of water vapor that will be present. So what is the total number of moles of gas? It will be 5 moles. Now the common mistake that students will make is to overlook the fact that this is a limiting excess question and do not account for the remaining oxygen gas. So they only look at the number of moles of products, which is 2 plus 2, which is equals to 4. This is a very common mistake. Now a very common trick that setters would like to put into questions like this is that they will add something like volumes are measured at RTP. RTP means room temperature pressure, and you will notice that the state symbols are not given. Now in such a question, the setter wants you to recognize this thing, that at room temperature pressure, water is no longer a gas. Okay, so if the state symbols are not given and the question mentions that the volumes are measured at room temperature pressure, you should not account for the volume of water vapor because it is no longer a gas. Meaning in such a situation, so volumes are measured at room temperature pressure, the total number of moles of gases remaining will be only that of oxygen and carbon dioxide. So 1 plus 2, which is equals to 3.